Greetings, welcome to our 47th episode of the FGI podcast series. My name is Tim Stark, and I'm a professor of civil engineering at the University of Illinois at Urbana-Champaign. On today's episode, we are going to focus on our February 16th, 2023 webinar titled Role of Geosynthetics in Combating the Effects of Global Warming. I'd like to quickly reintroduce our speaker for the webinar, and that's Tom Sangster, who is a professional certified civil engineer with more than 35 years of experience in geosynthetics and geotechnical engineering, and is the managing director of Downley Consultants, an internationally renowned consulting engineering firm specializing in geosynthetics and trenchless technology projects. Tom has undertaken and managed many geosynthetics engineering projects throughout the world. Tom, thanks for joining us again from Geneva, Switzerland.
It's a pleasure to be with you, Tim. Thank you for inviting me.
Oh, great, Tom, and thanks for an excellent webinar. And so we have about 4 questions that I didn't get to ask during the live webinar, and then we received a number after the webinar that I'll go through with you, and it would be great if you could provide an answer. So here's the first one from the live webinar that I didn't get a chance to ask you. Number 1, where can I get more information about the environmental impact of geosynthetics versus concrete?
That's a good question. The answer for geosynthetics is probably twofold. One is to go to the manufacturers. Most of the geosynthetics manufacturers who are operating and selling worldwide are required to provide some information, the life cycle analysis information in certain countries, so they have it. And those life cycle analyses will give you that information for geosynthetics. You can also visit the website of the European Association of Geosynthetics Manufacturers, EAGM, and that's www.eagm.eu. And they have a lot of information there for the environmental impact of geosynthetics in particular. It's a very good source of information. As for concrete, the concrete industry also has industry bodies, country by country usually, and they have a lot of information about the environmental impact, particularly the CO2 emissions. They may be a little more difficult to find because theirs is not such pretty reading.
Yep. Great, thanks, Tom. Next question from the live webinar. How is the environmental impact of the creation of the geosynthetics factored in?
Okay, well, if you recall or still have access to the webinar slides, there's a slide showing a breakdown of the life cycle analysis and also the environmental product declarations, which many of these products now have. And there are different stages that goes through, and the stage A is the product stage. So this covers stage A1, which is raw materials, stage A2, which is transport, and then stage A3, which is manufacture. So within that stage, you break down the data and you can see how much of the emissions or the environmental impact is in that creation stage from raw materials, and a lot of it is raw materials, and then manufacturing. In fact, those are the 2 biggest elements normally of the environmental impacts across nearly all of the categories. So that's where you find it from looking at the EPD or the life cycle analysis. But it's always that stage A, the product stage, where you can see what's embedded from the creation.
Okay, great. Next question from the live webinar. Did the environmental impacts discussed consider PFAS? And you could also throw in PFAS in the discussion.
Yeah. As far as I know, they don't. PFOS and PFAS are relatively recent, I'll say, discovery, and all their risks are a relatively recent discovery. And I think when the parameters for these life cycle analyses were set up, those specific things weren't there.
Okay. All right, last question from the live webinar. Where do the wind farm blades or the blades from the wind turbines get disposed?
That is a good question. I mean, these wind turbine blades are big, there's lots of them, and they're made of a resin-coated glass fiber, so they are not easy to recycle. Unfortunately, those that do come to the end of their life or get replaced predominantly end up in landfill. They're not a particular risk, they're fairly inert, but they nevertheless they end up in landfill. There are solutions, people are working on this to develop recycling methods. I mean, there are a couple around that are already up and running, at least at pilot stages. One is to cut them up, transport them, then shred them down to the size of gravel. Used as fuel then in cement kilns. You can recover up to 90% of the material and use it as a fuel in cement kilns. So we have the irony, since my theme in the webinar was how geosynthetics have less environmental impact than concrete, that we can actually recycle these blades, which are not geosynthetics, but recycle the blades to reduce the environmental impact of concrete, and it can be up to 25% of that process stage emissions. And there are other technologies. People are looking to separate fibers from the epoxy resin and reuse the epoxy to make new blades. So that really is, so they're trying to get this circular approach where you can reuse it and make another version of itself. So at the moment, the blunt answer is predominantly landfill, but there's a lot of work going on to find ways of reusing and recycling either all or part of those blades.
Great. Thanks, Tom. Okay, shifting to the questions we received after the webinar through the post-webinar survey form. Number one, is there a study on the negative impacts that come along with the use of additives, for example, carbon black in geosynthetics?
I haven't been able to find anything. So if there is, I'm not aware of it, of anything that looks at specifics like that rather than the whole picture. So I'm afraid I can't give you any better answer than that to that question.
Okay. Next question is, what special procedures or equipment are required for handling and placing GSCs? It seems that even a robust geosynthetic sandbag would not be as resistant to damage when being grabbed and lifted by a grapple as a comparably sized piece of natural aggregate. And GSCs, could you just go back and define that for the audience?
Yeah. Okay. The GSCs are the geosynthetic sand containers.
Yes.
These are a sort of engineered version to make them more robust of effectively what used to be sandbags. But we had a case study in the webinar of where these have been used to provide scour protection for the bases of offshore wind farms in the North Sea. And it's a good question. We're replacing rock. Rock is pretty robust. It's difficult to damage it. And you can with a geosynthetic sandbag. I've put this question to contractors and to a manufacturer, and the solution is to adapt the equipment. The grabs that you're using, they normally have teeth, and those are the problem. But by usually welding along those teeth, a cylindrical steel tube, so a little bit like a gum shield, if you can imagine, such as football players use, then you have that long length of cylindrical steel tube is what comes into contact with the bag and is much less likely to damage it. So you need to adapt the equipment by putting that, as I say, the best way I can describe it is like a gum shield over the teeth that is then what's picking up the bags to drop them into the correct places.
The mouth protector that like football players wear.
Yeah, exactly that. Sorry, gum shield is the English term perhaps, but mouth protector, yes, it's something that covers the teeth. It's basically a long cylindrical steel tube or cylindrical steel bar welded along all of the teeth to give a long bar that's picking up on each side, picking up the bags.
Right. And then the bags, would they lay across those steel rods and then you lift it up instead of?
No, they would be, those steel rods are on the end of the teeth on both sides of the grab. So
Oh,
the steel rods would grab the bag from both sides and pick it up.
got it. Okay, great. Thank you. Next question. Currently, what percentage of fossil fuel production worldwide goes to fuel/energy use compared to feedstock for geosynthetics and all the consumer plastic needs? Presume we face price increases in geosynthetic once renewable energy tipping point arrives.
Yes, there are a couple of parts to that question. I mean, the basic question, what the percentage is, I don't know, and haven't been able to find out. But it raises a key point, I think, that the questioner makes here. We need to distinguish between fossil fuels and hydrocarbons. Hydrocarbons can become fossil fuels, but they don't necessarily. Hydrocarbons are a resource. They only have their massive environmental impact when they're used as fuel, when they're burnt and the carbon is given off to the atmosphere. For a lot of the other processes where there are feedstock for geosynthetics, for polymers, for plastics manufacturing, that element doesn't happen. So they're a valuable resource. And I think we do need to distinguish between hydrocarbons and fossil fuels. So that's sort of part of the answer, but the actual percentage numbers, I don't know, and haven't been able to find a reliable answer to that. But the other part of the question, or the comment, we presume we face huge price increases in geosynthetics once renewable energy tipping point arrives. That is a real risk, I think, across all of polymer-based or plastic-based materials. Once there's less supply of hydrocarbons because it's less cost effective or less profitable for people to get them out of the ground because they're not being used for the fuels, which is probably the big use. Then, as we've seen already, the crackers get turned off, there's less supply, and it tends to push prices up at the raw material end. And that is a long-term systemic risk I think this industry faces.
Yeah, great point about differentiating hydrocarbons from fossil fuels. I think they just get lumped together.
Yeah, I mean, some of the hydrocarbons become fossil fuels, but that's up to that point, while they're in use as plastics, which could be over 100 years, for example, in geosynthetics, then they're not creating those CO2 emissions.
Right. Okay. Next question: are increasing CO2 emissions beneficial or harmful to the planet overall?
I think the evidence is overwhelming that they are harmful to the planet. There's a counter argument that all we're seeing is a typical cyclical weather pattern of warming and cooling, and there've been ice ages in the past, and you look back and there's plenty of historical archaeological evidence for that. But the reality is what we're seeing now is not just a cycle like that. There's a clear cause of the global warming. The CO2 emissions cause warming, and the effects of that are what we're seeing in climate change. And I think it's overwhelmingly clear that these emissions are harmful to the planet, and not only to humanity, to the planet.
Great. Okay. Next question, Tom. What research has been carried out on the lifetime of geosynthetics used instead of concrete? How will geosynthetics degrade, and what will be the impact of the degradation products? Boy, that's a lot.
Yes, it is. We could spend an hour or so debating that one, but I'll resist the temptation. In terms of the lifetimes, in essence, where the research has been done is not so much on lifetimes, but on, again, in the life cycle analysis. It takes into account the lifetime, the end of life, specifically of the particular materials, the geosynthetics. So we know when they're expected to degrade. I don't think, or I'm not aware of any research in terms of impact of the degradation products, but certainly the life cycle analyses do go right through to end of life and disposal or reuse. How that compares with concrete, honestly couldn't say without looking at several life cycle analyses of concrete. I mean, concrete we know can be reused. It can be ground down as aggregate for, to be reused in concrete. So I don't know if any comparable research there has been carried out on that specific point.
Okay, great. Tom, last question from the post-webinar survey. To your knowledge, is there any country or city where low-impact engineering solutions are already mandatory? Can you predict whether or when this will happen in a broader sense, and that being mandatory?
Yeah.
Yeah.
At the moment, I'm not aware of any where this is mandatory. What we are seeing in some European countries, and I'll pick out the Netherlands as being the one that is doing this, they're mandating they want to see environmental product declarations for all the construction products being used, so they can make comparisons and evaluations based on the environmental impact of the products used in these engineering solutions. So that's driving towards low impact engineering solutions. The low impact engineering solutions themselves are not mandatory, but we can see that as a next step, or at least the environmental product declaration data being used as input to choices and selections that engineers have to make in designing and developing the engineering projects, the engineering works. So it's starting to happen. It's happened in the Netherlands. I would expect some of the other northwest European countries, especially Scandinavia, to be not far behind. Germany as well. So it's starting to happen. I think over the next 10 years, we'll see it as commonplace in Europe. The speed at which it gets picked up elsewhere in the world is difficult to say. But I think once Europe is doing it, people perhaps will see whether there's a benefit, and if so, whether they want to go down the same road.
Okay, great. Tom, that's all the questions we have today. So thank you so much for joining us again from Geneva, Switzerland. Listeners, if you have any additional questions or would like additional information, please send your questions to Tom. And Tom, do you want to give everybody your email address? I'm trying to find your slides.
Yeah, no, I'll read it out. It's tom.sangster. That's spelled S-A-N-G-S-T-E-R, kind of like gangster, only with an S at the beginning. Now you won't forget. At downley.com, and Downley is D-O-W-N-L-E-Y. tom.sangster at downley.com, and I'll be happy to answer any questions you may have. Or you can send, they can send them through to you at the FGI, and you'll pass them on.
Exactly, at fabricatedgeomembrane@gmail.com. And Tom's email address is on the last slide after his presentation. So if you didn't capture that, you can capture it off the last slide, which is on the FGI website. Okay, so Tom, thank you so much again for joining us from Geneva, Switzerland, and for an excellent webinar.
Thank you, it's been my pleasure.
Okay, all right, Tom, great. Thank you so much. And when I hit end, the whole thing is going to end. So thanks, we'll be in touch soon.
All right, I hope that gives you what you wanted. And,
yep.
Yeah, we'll stay in touch, no doubt.
Great, thanks, Tom.
Cheers, Tim. Bye-bye. Bye.
Safe travel.
Thanks.